Here we are in Chapter 5 review exercises, numbers 11 through 16. Let's solve these with our three-step process. Number 11, do we have parentheses? No. Do we have fractions? No. Do we have many p's? We do have many p's. Let's get them together. Let's get rid of this term with p's over here, add 7p to both sides, and we now have 14p plus 12 equals 13. And notice, once we get to that step, we have two things left to subtract. We have 4p equals 1, 14p equals 1, and then divide by 14. Divide by 14, and we get p equals 1/14. Not really anything better we can do with that guy. Okay, number 12. Do we have parentheses? We do. We can jump that guy in. Now take that negative with it. So we have 4n plus 68 equals 7 minus 2n plus a 4. Do you have fractions? No, but we do have many n's. So let's add 2n, add 2n. On this side, they're gone. This side, we get 6n plus 68 equals 11. Subtract 68, subtract 68. 6n equals what? 11 minus 68, that's, you see, 68 minus 11 would be 57, but the negative 1 wins. Divide by 6, divide by 6. I don't know if that simplifies. Let's double check. 57, let me see. 6 goes into 57, 6 goes into 5. No, 54 is 9 times. Yeah. 9 times 6 is 54. Subtract, we get a 3. Let's put a 0 there. 6 goes into 35 times. 9.5. Interesting. This comes out to be negative 9.5. That was not a bad decimal, which means that you could divide top and bottom by 3, and you would get negative 19 halves. These two are the same number right here. Okay, that is not obvious. All right, next one. Number 13. 7x minus 10 equals 5x minus 2. Are there parentheses? Yes, let's distribute. So we get 7x minus 10 equals 5x minus 10. We have many x's. Let's get the x's together. Subtract the 5x from that side. Subtract 5x from that side. Those guys are gone, and we have 2x minus 10 equals a negative 10. Add or subtract, so add 10 to both sides. We get 2x equals 0. And then when we divide by 2, we get x equals 0. Okay, number 14. 9x minus 4 equals 15x. Are there parentheses? Nope. Are there fractions? Nope. Are there many x's? There are indeed. Let's subtract 9x from both sides. And we get negative 4 equals negative 6x. Nothing to add or subtract, so now divide by the negative 6, divide by the negative 6, and we get x equals negative over a negative is a positive, and that reduces to 2/3. Good. Number 15. 8x, we got parentheses, so take that negative 7, jump it in. So we got 8x minus 7x minus 21 equals x minus 21. We don't have fractions. There are many x's. Let's combine these two together. They're on the same side, so we don't add or subtract from each other. That's just 8 minus 7. That's 1x minus 21 equals x minus 21. That smells fishy. Let's get the x's together by subtracting this x from both sides, and we look, and yep, something happened. Negative 21 equals negative 21. Yes, that always is true, which means x is all numbers. And you could see that actually right here. If you put in x equals 7, x equals negative 19, x equals 53, anything you stick in for x, these two sides are exactly the same all the time. Always true. And that means x could be anything. Number 16, we don't have any parentheses. We don't have any fractions. Well, but we do have decimals. Let's go ahead and clear out these decimals. This will be pretty nice. Times by 100, times by 100, times by 100. Oh, there we go. So we have 18x equals 1300 minus 22x. No decimals, no fractions. Now these multiple x's, we could add 22x to both sides, add 22x, and we get 40x equals 1300. Divide by 40, divide by 40, x equals, let me see, that's 130 divided by 4. Now we could we could reduce that, divide by 2 and divide by 2, and we get 65 halves. Or you notice we could just do 4 goes into 130 like that and get a decimal. 4 goes into 13 3 times. 3 times 4 is 12. Subtract and we get 1 0. Drop that down. 4 goes into 10 twice. 2 times 4 is 8. Subtract and we get a 2. If we put one decimal on there, 4 goes into 20 5 times. So 32.5. Or having simplified this fraction down, we could do 65 halves or 32.5.